Polyether is a colourless organic thermoplastic polymer in the polyaryletherketone family, used in engineering applications. Synthesis. PEEK polymers are obtained by step growth polymerization by the dealkylation of bisphenolate salts. Typical is the reaction of 4,4-difluorobenzophenone with the disodium salt of hydroquinone, which is generated in situ by deprotonation with sodium carbonate. The reaction is conducted around 300 degrees Celsius in polar aprotic solvents, such as diphenylsulfone. Properties. PEEK is a semi-crystalline thermoplastic with excellent mechanical and chemical resistance properties that are retained to high temperatures. The processing conditions used to mold PEEK can influence the crystallinity, and hence the mechanical properties. The Young's modulus is 3.6 gigapascals and its tensile strength 90 to 100 megapascals. PEEK has a glass transition temperature of around 143 degrees Celsius and melts around 343 degrees Celsius. Some grades have a useful operating temperature of up to 250 degrees Celsius. The thermal conductivity increases nearly linearly versus temperature between room temperature and solidus temperature. It is highly resistant to thermal degradation as well as attack by both organic and aqueous environments. It is attacked by halogens and strong Bronsted and Lewis acids as well as some halogenated compounds and aliphatic hydrocarbons at high temperatures. It is soluble in concentrated sulfuric acid at room temperature. Although dissolution can take a very long time unless the polymer is in a high surface area at a volume from such as a fine powder or thin film, it has high resistance to biodegradation. Applications. Because of its robustness, PEEK is used to fabricate items used in demanding applications, including bearings, piston parts, pumps, HPLC columns, compressor plate valves, and cable insulation. It is one of the few plastics compatible with ultra-high vacuum applications. PEEK is considered an advanced biomaterial used in medical implants. It is finding increased use in spinal fusion devices and reinforcing rods. It is extensively used in the aerospace, automotive, and chemical process industries. PEEK's mechanical properties at elevated temperatures have led to it being used in at least two varieties of rep extruder as thermal insulation. This means the main mechanical structure of the extruder can be made of the same material that is being extruded, provided that the PEEK insulator prevents heat from traveling beyond the intended melt zone. Processing options. PEEK melts at a relatively high temperature compared to most other thermoplastics. In the range of its melting temperature, it can be processed using injection molding or extrusion methods. A San Francisco company demonstrated for the first time the technical possibility of processing granular PEEK into filament form and 3D printing parts from the filament material using fused deposition modeling (FDM) technology. In January 2016, the German startup Indmatec GmbH, located in Karlsruhe, presented a PEEK filament for producing medical devices up to Class A. With this new filament, it is possible to use the FFF method for different medical applications like dentures. In its solid state, PEEK is readily machinable, for example, by milling machines, and is commonly used to produce high-quality plastic parts that are thermostable and both electrically and thermally insulating. PEEK is often considered a high-end engineering plastic, such as Delrin, PTFE and nylon. Shape memory PEEK in biomechanical applications. PEEK is not traditionally a shape memory polymer. However, recent advances in processing have allowed shape memory behavior in PEEK with mechanical activation. This technology has expanded to applications in orthopedic surgery.